Today's webcast learning objectives include identifying fire risks associated with lithium-ion batteries in facility environments, learning best practices for safe storage, handling, and emergency response, understanding code requirements and fire suppression system considerations, and finally, gaining strategies to train staff and improve overall fire safety preparedness. Now let's learn more about our presenter. Tracy Bellamy is the Chief Engineering Officer with Telgen Engineering and Consulting. Tracy joined Telgen in 1996 when it was then known as TVA Fire and Life Safety. In 1999, he was elected to the board of directors. With over 30 years of experience in the fire protection industry, Tracy is active within the National Fire Protection Association and represents Telgen on a number of NFPA technical committees. He is also a certified instructor with NFPA and teaches nationally and internationally on a variety of fire protection topics. Tracy is also a member of the Society of Fire Protection Engineers, or SFPE, and currently sits on the Board of Governors of the Greater Atlanta chapter. A registered professional fire protection and civil engineer, Tracy is a graduate of the University of South Carolina with a bachelor's and master's degree in civil engineering. In addition, he holds an advanced graduate certificate in fire protection engineering from the Worcester Polytechnic Institute. And with that, I'll turn it over to Tracy.
Appreciate that. Thank you for the introduction. Although after you read all that stuff, I go like, oh my gosh, I'm getting old. Appreciate you guys tuning in today for the topic on lithium-ion batteries. It's certainly something that's pervasive in our world. It's everywhere, and we've got to get a handle on this. I think the technology, somewhat, in my opinion, outran the protection community, where we were seeing things introduced that were very effective and very good at what they did in terms of energy storage, but produced or introduced risk to our society that we now are trying to do some catch-up work to get a better handle on exactly what we need to do with these items. There's another bio thing or whatever. I think, I think there's a couple of differences there, but, read that at your leisure. I go like, blah, 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 read it for whatever that's worth. Listen to what I maybe have to say today and then see where we go from there. But I want to start out where we think about lithium-ion batteries and where they are in our world. And I'll go through a few slides here and spend some time just pointing out some items and things like that are shown there on the screen. But more so, I'd like you as the listener there to think about your world, in your home, in your office, in your operating facility. Where might you find a lithium-ion battery? We look at this screen here. It's laptops and phones and cameras, watches, tablets, vacuum cleaners, anything that was previously plug-in power is likely got a lithium-ion battery-driven alternative out there for portability, convenience, you name it. We have these certainly all over our home, our offices. We deal with these every day. Every one of us likely has a phone in our pocket that we carry around, or a watch that we're wearing that likely may have this technology associated with it. Now, the amount of energy associated with those is certainly not the same as some of the energy storage systems and stuff, but we do recognize that we have had problems over time. Something like the phones. I think Samsung a number of years ago had a significant issue with a phone that was spontaneously igniting. It was going into thermal runaway. They had to address that. That's out there. So we do know we've got plenty of devices around, certainly in our common stuff. Larger capacity units start showing up in automobiles, the Teslas, the Rivians that are out there. They're certainly out there. Every manufacturer has an electric vehicle. There's a demand for that. They're coming out there, but it's moving into things beyond just the individual vehicles. You've got boats, you've got commercial vehicles that are now being powered through the electric platform, and introducing these in much larger formats and larger amounts of energy that represent that significant hazard that we have out there, down to even the e-bikes and e-scooters that we see out there. I know recently, in the recent past week, there was a significant number of events that were occurring in New York City, and New York City started reacting to that, saying we have some significant events that have prompted us to try to put some local regulatory requirements in place to try to address some of the hazards that were going on, even in the individual residential units that were out there. And it kind of gets hard to start to try to tell people what they can or can't do in their homes out there. There's larger energy storage applications, the energy storage systems, the windmills, the solar panels collecting large amounts of energy. And there have been significant events with that. I think it was in Surprise, Arizona. They had a very significant event there with some injuries, and there's some concern there that we have to do that. They're going into residential applications, or even, you know, the power tools. We've all got those or things in our house. A recent, I say recent, probably a year or two ago, I guess now, one of the individuals in the industry that I've worked with quite a bit in the sprinkler industry, a guy, James Gullenbow. I think I saw him about a week after this event, but his house caught on fire, he believes, due to a portable drill battery that was charging on his deck. Covered deck, and ended up burning his house down. So, you know, we all have to recognize that these things are showing up in our homes. I've got them in my garage. You've got them in your garage. That sort of stuff that we have to be aware of. Other applications could be, you know, flashlights, lanterns, energy storage type portable power units. We've got them in, you know, the e-cigarettes or whatever. Just tons and tons of things that have this particular technology available out there, and we're seeing it just show up everywhere. I think, I want you to take a moment in your mind and think, where do I have these? You know, flying on the plane, like I say, that they ask you now, I think I was saying earlier that, you know, they ask you, do you have any spare batteries or laptops or anything in your computer or in your checked baggage? Because there's concern that those particular items might go into thermal runaway, might represent a hazard. And if they're in the cargo compartment of that aircraft, there's no one that could do anything about it. On board the aircraft, at least maybe somebody could take some action. They carry bags where they could place that in there and try to mitigate the risk and stuff like that. But these things are a part of our day-to-day life. And I believe we've come to get, I'll say, complacent. I think that's the last question on that slide. But, you know, these things are everywhere. And we have to have a knowledge of that, or at least a respect for that, so that we can take proper precautions to address that. These things are part of our normal life. I think even something in the past, I had a lady that worked with me whose son was severely injured when he was messing with gasoline, and got gasoline on him, and it, just a small spark from a nylon brush he was using to scrub something with it caught it fire, and very significant injury. And I believe that the hazard was always there, but we just became complacent with the fact that these are things that are just commonplace in our lives. And I think even some of the stuff with energy storage systems that I've seen over time come up is energy storage systems that might be associated with a continuous operation of something like a freezer. I've seen that in some pharmaceutical type things where they have a freezer they need to make sure that this product remains at a very, very cold temperature. If they had a power outage that resulted in some extended period of time, the product would be ruined, and these are significantly expensive products. And they end up putting an energy storage system on board with this particular sold unit. I've had, you know, customers say, I didn't even know I had that in my facility. It was not part of something that they necessarily said, hey, I need an energy storage system, but the performance metrics that they laid out for the vendor providing a particular freezer unit was that it needs to do this, and the vendor, you know, met that need certainly, and took that on. So now I want to look, you know, what is the hazard? And I'm going to show a couple of videos here, and there's a photograph on this page that kind of illustrates you know, what one might look like. This is a little scooter that went into a thermal runaway. And if you, so we look at these, I've kind of after each one, maybe explain a little bit or add a little commentary after it. But I want to kind of maybe think about where this might fit in our world as we look at each of these. So we'll start with this first one here. Let's see if I can get that going. There we go. I don't think this one has any audio. This is a large refuge facility or processing trash or whatever. But if you see a small fire starts there off in the corner, not a large, doesn't look like it's something that would be necessarily endangering to the occupants or what have you. But thinking about that particular video and looking at what we saw there, think about what's going into your trash stream, into your compactor in your building. You're compacting cardboard or trash in a facility. You have an increased, even if the ultimate release of energy is not something that is that big of a concern, it is a pervasive ignition source that could lead to a much bigger fire with the combustibles associated with whatever area that thing's in. I've had that opportunity in some distribution centers where they have a waste stream where the products are being unloaded out of cardboard. The cardboard's going on a conveyor, being compacted and baled up. A lithium-ion battery got into that stream as the compactor was trying to crush things. It breached that particular battery, and we ended up having a fire event that was associated with all the combustibles that were in that area. So while it wasn't like that, the release of energy from the battery wasn't, by itself wasn't the hazard. It was the burning combustibles that were associated with that initial ignition out there. So next video is in I think this is in New York City, in one of the, let's see if this will get going. That particular video was obviously produced through the FDNY through some of the concerns they had with these e-bikes igniting. And you can look at the level of intensity and the speed at which that particular room was engulfed with fumes and smoke and energy being released, and the hazard associated with that. The next video is a similar one, but it's in a residential setting. And I kind of, this is New York again, promoting this, that when you think about these that might be in your home, let's see if we can make sure this gets going. Very short video, but an intense developing fire. I think that was done through UOFSRI, Fire Safety Research Institute. They've done some other testing with vehicles in a garage and vapors that are fumes that might be released and ignited in a flammable vapor form within the facility. But the intensity of that fire and the speed at which it grows is incredible. And when you look at that, and then the next video or final video I'll look at here is one that was produced by ULFSRI. I think it was Dan Madrukowski over there. I know my son worked over there for a bit, but it's interesting that you can look at the technology and the size of the cells. I think, to me, when you look at this, the size of the individual cells, 18,650 batteries, and the amount of energy that's released just from a single cell in some of this, and even multiples, is quite enlightening, if you will.
Today we're in the fire lab. We're going to be testing lithium-ion batteries. We're going to intentionally overheat them where they will catch fire and or explode. When you look around the home environment, you'll see that there's a range of battery-powered devices, something like a toothbrush or a shaver, lawn equipment, power tools, all the way up to a battery-powered vehicle. A personal shaver such as this would be powered by a single cell. Keep in mind that the amount of energy stored even in this single cell can cause fire and sparks and potentially even explode if mishandled or overcharged. If you have a larger battery pack that has dozens of cells or hundreds of cells, that can burn for a more extended period of time. We call it thermal runaway. It overpressures the cell and causes flammable gases to vent out of the cell, or it could even cause the cell to explode. To help people understand what to do and how to handle batteries safely, FSRI has developed the Take Charge campaign. The key things for people to take away from this are buy certified products, make sure that they follow the manufacturer's guidance in the charging, use, and recycling of those products. We need people to keep in mind that batteries are in products and devices they use every day, and that appropriate handling and charging of those devices will prevent fires and keep them fire safe.
All right, I think, let's see here. Yeah, there. A couple of things he talked about there about listed products, and you'll see some of that in the code requirements about listed products and listed charging devices. I think that's one of the things we certainly can control as consumers in what we buy. The products that we get, that certainly if you went out to buy a replacement battery for a drill, let's say, that you have, and you go to the manufacturer's product line and say, okay, I'm going to buy a branded whatever you want to say thing. The cost of those is quite expensive, right? Certainly, and I was guilty of this too. I think I was shopping and went in and started clicking. Said, wow, that's a great price. I clicked on it and I ordered the batteries. And the batteries actually arrived at my house. And I got to thinking about it. I said, I wonder why these are so cheap. They were actually branded batteries that looked exactly like the brand that I have. But I started doing a little research and checked a few things, and they were counterfeit batteries, absolute counterfeit batteries. And the batteries themselves contain a number of features that prevent them from overcharging. There's battery management stuff that's going on in there that's associated with that. You don't know what you're getting if you don't get a authentic listed product that's out there. And I think some of that with the New York City stuff might have been a pervasive thing. You saw a bit of that in some of that. If you buy illegal batteries, I think is what they said. But this is something that we can certainly do, buying a listed product, and we'll see some of the energy storage systems out of 855 or the International Fire Code are leaning now toward full-scale testing to prove that you can properly protect those. This industry certainly took off with good ideas to store more energy in smaller packages, but we have to understand what that risk is. I know personally, I was at Underwriters Laboratory some time ago. There were some tests going on some energy storage systems in one of the labs. We were asked not to be in the building that day. We were running some other types of tests, and we were in an adjacent building, several hundred feet away, and whatever happened in the room that day shook the ground. Felt like a little earthquake or something. And so I know there's massive energy there, and the codes and standards, and I want to go through, these are the most current editions of these documents. International Fire Code 2024 is the most current published, along with NFPA 1 in 2024. And the 2026 edition of 855 has just been published, I think maybe a week or two ago, has been put out on the streets. I expect all of these to continue to change. There's a new NFPA 800 for battery safety that's currently proposed. Committees being accumulated or put together to address that. There's a huge amount of interest in that. Right now, the battery stuff is going in with the energy storage system stuff that was in 855. It's one of the chapters. We'll look at some of the stuff in there. But I would expect, even though we talk about things today and we can say, yes, this is current, this stuff is going to change quickly. And I think that's one of the things that I have to be to admonish folks about is we've got to be careful that we don't, say, well, I know, I read this and I know. And I also want to kind of warn people a little bit in this. When we talk about codes and standards, those codes and standards don't become mandatory in a legal sense until they get adopted, let's say at a state level or local level. Many of our localities are certainly not going to have adopted these additions, certainly not the 2026 855 as it's just been published, but it will come as consumers or operators of facilities or design engineers or risk engineers, fire protection engineers. I think it's incumbent upon us to look to the best available knowledge in the industry to make informed decisions, as opposed to saying, yes, I don't need to do anything here because that yet hasn't been adopted. The risk is still the same. I think it's important that we try to make sure that we do read, particularly in this field of rapid advancement out there. And I know we talk about lithium-ion batteries. There's more battery technologies out there. I expect them to change, and there may be additional risks that we have to go through and look at. There's specific sections now in the fire code and in 855 that address lithium-ion batteries. In the case of the IFC, and we'll go through some of these quickly. It talks about there's requirements here to apply, and it gives a whole bunch of exceptions on that. Batteries that are in equipment, batteries that are packaged with equipment, stuff like that. Batteries that are small enough, less than or equal to 300 watt hours, with less than or equal to 25 grams of lithium metal. Those things, temporary stuff going on in the building. So there's some outs there that take away a number of the things that might be that these regulations won't apply to. But we do still have batteries that might be stored in a building that we have to address here. Got to have permits for stuff. You have to have a fire safety plan. You need to understand what the risks are and how you're going to deal with that if you did have a particular event out in the field. If you look at the IFC, they talk about how do you store them, and there's a number. I think it says 2. I think there's 3 options here that it goes through and provides for you to store these batteries that are out there. So indoor storage, it says you can have up to 15 cubic feet of batteries permitted in a container in accordance with these requirements: open top, non-combustible material container, no individual container, exceeding 7.5 cubic feet. You might think, well, what the heck, 7.5 or 15 cubic feet? If you look at 7.5 cubic feet, that is roughly a 55-gallon drum. With that, you could have multiple groups of containers as long as you keep them apart by 3 feet of open space or 10 feet of space if you have interbedding combustible materials, packaging, things sitting on the floor. There's also some directives to try to keep them away from exit doors and exit access doors. As you looked at certainly the scooter video in the residential application, how quickly that event occurred and how extensive it might extend out from it. You have to think that, are you going to block an exit door, an available exit? I would certainly personally think about putting stuff, if the single exit from a space, the single available exit from a space it has these stored near it, I'm not sure I would be comfortable with just the 5 feet or more than 5 feet. I would think I don't want to block the only exit with the installation or storage of these things in there. Talks about storage in a building if we go over those limits. Once you go over those limits, then you have to start getting a more substantial level of protection or separation within those areas. You have to put together a technical opinion and evaluation report. Essentially, I think some of them in the 855 talk about hiring an engineer or something to come in and do this report. So when we start getting into more substantial storage, we have to really start looking at these things a little more detailed, provide an evaluation report to understand what's going on in terms of potential for deflagration, potential for uncontrolled fire, design of our sprinkler systems, that sort of stuff. How do we do that? There's so much we don't know yet with this industry. Located, if it's in another building or with a building with other stuff, 2-hour fire rated separation between that, or it could be in a portable prefabricated unit that's 2 hours separated. They do allow battery storage is in new packaging, as long as the packaging can contain the event. So that's another avenue, but I don't know that's pervasive out there. The sprinkler protection, essentially what the IFC said with these larger quantities, it says you have to protect it with a automatic sprinkler system or other approved alternative that's been demonstrated to be correct through some sort of analysis. I'm thinking large scale testing to prove this. You also have to have detection system in there, and using an air aspirating or radiant energy sensing type detection system in those areas. Those are expensive. Those are not just putting a smoke detector up. Those are substantial costs to those. So you need to just be aware of how that might impact us. Explosion control. These particular devices in that thermal runaway they do produce or release flammable gases. And if those gases do not ignite, you can have an explosion potential in there. That's one of the things I think UOFSRI did with some of the vehicles in a garage. You may have the opportunity for a buildup of those. You have to make that consideration as to whether that's going to be an issue out there. I think the event with the ESS out in Surprise, Arizona, I guess that's kind of a fitting name, because it was quite an event, resulted in some explosions that occurred due to built up vapors there. You are allowed to get away from several things here, get away from the technical opinion report, the 2-hour rating, the explosion control, as long as the state of charge of the battery is limited to and verified to be less than or equal to, or no more than, I guess, 30%. It is a recognition that the amount of energy within that cell is indicative of the hazard that might be associated with it. The lower state of charge, the less likely it is to go in the thermal runaway, the less energy that can be produced or released out of that. You still have to put sprinklers in. You have to still have the fire alarm system, or not. They're not part of the what's exempted out of that. You could also go outside with these. There's a couple of ways you can put these outside, and that might be something that's advantageous, certainly from a risk standpoint. But then you got to put that a certain distance away from the building. There are some allowances to put it under like a maybe outdoor, but it's under a shed or a roof out there. As long as it doesn't exceed 25% of the perimeter of the space, it could still be considered outdoor. Maybe some weather protection to keep you from ruining them. But those still need to be at least 20 feet away from the building, lot line, street, public way, all that stuff. You could reduce it to 3 feet as long as you 2-hour rate the walls between the two of them with 5-foot extension to the sides and above it, type thing. Or you could do that same thing if you had a prefabricated enclosure that had the same 2-hour rating. It's not any different than the item number 2. But for that, you need to limit your storage area per pile to less than the 900 square feet, and the height of the storage to 10 feet. With the multiple battery storage areas being separated one to the other 10 feet per pile from each one out there. The automatic detection is required based on the environmental conditions out there. They look to go with a radiant energy sensing detection for that out there. Let's see here. NFPA 855. Which is energy storage systems in chapter 14, they basically address lithium-ion battery storage. One of the things that I think you will see as NFPA 800s develop, all this stuff will move over there. But it was kind of like they had no place to put this. There was a recognition there was a hazard. Let's put it in this standard. Again, a lot of these are going to be very, very similar, if not exactly what you saw in the fire code. And I think you'll see that they tend to somewhat mimic each other. I don't want to say copy because somebody will go, well, there's copyright laws. And I think there is, but the 30% charge, they kind of backed out of, in 855 backed out of requiring compliance if you kept the things to the 30% charge. They also allow you to do some testing. And I think currently that's the encouragement that we're seeing is, hey, we need to run some tests and prove that what we have is not a hazard. It can be controlled by the installed protection systems being sprinklers. It doesn't impede the occupants from leaving or impact adjacencies that might be in close proximity to that. And then they have the same allowances there for vehicle, those that are in vehicle or packaged or in equipment vehicles or whatever, and those packaged along with that. Same 300 watt hour, 25 gram lithium ion in the original container. Then they have some allowances for, in production facilities where they're staging it to be produced or whatever. And then where they're being repaired or in use and staged for swap out. So there's some operational allowances. That doesn't mean there's no risk there, but they're trying not to overly burden that thing. This is a temporary allowance of storage of components that are being compiled or put out there for energy storage system installation. You can do that as long as you don't go over to 50% charge, and there's some duration that gets approved. Simple stuff like that. In terms of storage of the lithium-ion batteries, once we get above some of that, with same individual container size, 7.5 cubic feet, no more than 15 cubic feet. The single 55-gallon drum, the 15 at 7.5 cubic feet, and 2 at the 15. Same separations, 3 feet or 10 feet with combustibles in there. You'll see 5 feet from an exit that's out there. Same thing for the container type. It's very much the same, but I expect these are still going to change, certainly when we get NFPA 800 in place. It gives some additional requirements, so something quite common to protect the battery terminals. I mean, even with a typical lead aspect, you protect those terminals so that you don't have a short that could occur between those, making sure they're protected out there. I think that's pretty commonplace. Separation of the spaces, when we look at that, same 2-hour separation, same fire alarm system required. It says smoke detection from, it introduces a thing about thermal imaging detection, which is a different method than the radiant energy and the air aspirating or smoke type detection that would be required over in the IFC. But I expect they're probably going to all catch up with each other. Sprinklers installed according to the NFPA 13 in there, or you could go to a prefabricated structure. And the prefabricated structure has the same exact criteria as a stick-built one with the 2 hours, the detection system, and the sprinklers being required in the building out there. Or you could put the product in metal drums. Here they're adding some stuff that wasn't in the fire code, talking about put the individual batteries in there and separate them with vermiculite or some other approved material that can be proven to contain that event that's out there. I think it's certainly something that we need to consider in terms of propagation of the event from one battery to the next. I've actually done some testing with some water-based stuff where we put it in an enclosure and just threw copious amounts of water at this thing to prevent the event from spreading from one battery pack to the adjacent battery pack. Outdoor storage area containers area must be less than the 900 square feet, separated by 10 feet, the alarm system, all that out there. Sprinklers with in accordance with NFPA 13. They do have an allowance for containers approved for transportation. If they're permitted to be stored in those containers where it's been proven or shown that it won't propagate beyond the container and complies with some particular criteria. And if we have that, certainly we go back to the 900 square feet to 10 feet between containers, sprinkler system, fire alarm that's out there. You need a plan. Same thing the fire code kind of pushed on about having a plan for prevention and early detection mitigation. How are you going to do that? Get with the HJ. I think we also need to have the interaction with the fire service that they understand what is in these facilities, depending on what's stored there, how much. We got to check the mitigation plan needs to prevent, containment or provide for containment of projectiles, know what you're going to do after post event, how you get there and clean it up, how you going to remove the materials. These are all things that need to be addressed or thought of well before we have the event. Explosion protection, again, same exact thing, got to be analyzed, explosion protection provided as necessary. When we look at that, I think these things just get put in and we go, well, how much flammable gas will be released? Is it ventilated? Is it not ventilated? Is there an ignition source there? All of that has to be considered in these storage application. Outdoor storage, 900 square feet, 10 feet tall, 20 feet from, and the same exact things. You can see this is written a little bit differently, but very much exactly the same provisions throughout all of this. Weather protection, 25% open, or up to 25% closed, I guess. Is a better way at that. They did add a limit on the size of the structure to 3,600 square feet, the total size of this out there. Fire alarm system being outside is limited to radiant energy or thermal imaging detection. Again, same thing. Smoke detection is not really conducive to that environment out there. And there's a special section. This kind of changes gears a little bit here. And there's a special section that's been introduced into the IFC in 322 about micro-mobility devices. And these devices were the e-bikes and the scooters and things that were problematic in some of the, and you'll see the International Fire Code here has some requirements, and there's NFPA 1, which I mentioned earlier, has some additional requirements that we would want to look at. But these are devices that we've seen problems with, or that we've had problems in the past with. They're basically saying they have to comply with this section. They do have some exceptions there to say, hey, the storage, repair, charging in a residential unit for personal use by its owner is exempted. That doesn't mean there's no hazard. That just means that they're not going to regulate it in terms of like an individual's home or their domicile. They're not going to do that in this, charging a single device in an occupancy by its owner out there. I know I've had customers that have engaged me that have larger business or office type buildings, and they have a lot of their associates that are each one wanting to bring, and we'll look at the NFPA 1 as well, they're wanting to bring in their e-bike and charge that in their office. And there's multiple in there. There's things in here to talk about listing the product. And one of the things I pushed on was, how do you control that individual that brings in a unit is a listed unit? Or are you going to have to get them inspected? Or are you going to continuously look at the charging unit? How are you going to do that? A number of folks have said, we're just not going to allow you to bring them into the building and charge them in the building. We will give you a space outside to keep them, but it's something we have to have a handle on. By a code standpoint, you could possibly say, read that second one, say a single device in any occupancy by its owner. Does that mean a single device per owner, or does that mean a single device in the building? I've seen, depending on how you want to read that. I would personally probably say they're letting you put one in, but when you start doing multiple, they specifically say residential occupancies can't be used for commercial charging operations. Battery equipment, again, I think Dan Madrikowski mentioned this, use listed equipment, have listed product, listed battery charges, or whatever. If you use the one that came with the product, or make sure that you get a listed piece that does that. Those devices, certainly UL has a listing standard for the electrical systems for personal e-mobility devices and e-bikes that are out there. I would certainly look to that to provide some level of insurance. We had a proliferation of non-listed products that were coming into the market, and I think they were selling quite well because they tended to be a more affordable unit that ended up creating a potential the potential problem that we saw, or the ultimate problem that we saw out there. Charging area, you only use the listed charging equipment. You got to have a receptacle to plug each individual unit in, or a plug. Don't put in drop cords or power strips and that sort of stuff. Make sure you remove any adjacencies or combustibles that are located that might be located in the area away from these. Don't obstruct the means of egress. And that's to me, a means of egress technically is anything between you and getting out of the building. Anything between you and getting out of the building. And if I was sitting in my office and I put the e-scooter beside my door, the only door out of this office to get out, I think I obstruct the means of egress if I have an event that occurs. It's being mindful of that sort of stuff. I think folks are saying, well, it's not near the outside exit door. Means of egress to me is anything between you and getting out. Don't remove the batteries and stack them and all that. It's about, someone kind of commercially wanting to take a bunch of batteries out of the units and stack them up. beside each other. Maintain at least 18 inches between batteries if you're charging them, so you don't heat one. You're trying to limit the propagation of an event from one to the other, to the other, to the other. Same 18 inches would apply if you have a battery that is part of a unit that doesn't get removed in your charger. Try to give some spatial separation between the two to limit the exposure from one to the other. I think there's a little caveat in there about possibly providing some sort of fire resistive separation or material between the two, so an event won't propagate from one unit to the next unit to the next unit. The area needs to have the air aspirating smoke detection or radiant energy detection. Again, these are the radiant or the air aspirating, something like Vesda or Modulaser, or there's a bunch of brands out there that make that. I think Vesda, I think, was the first one out there. Fire safety plan, again, understanding what emergency actions need to be taken upon detection. What do you need to do? How do you need to notify folks? Where do you need to get folks? How do you need to get summons folks to the scene or what have you out there? NFPA 1 also goes in to this micromobility issue. They set a limit at 5. If you've got greater than or equal to 5 micromobility buys charged inside of a building or within 10 foot of the building, you got to comply with these requirements. They do give some outs a little bit on there in the definition for a micromobility device. They did want to have this regulate motor vehicles, cars, things like that, I suppose, motorized wheelchairs, medical scooters, shopping carts, golf carts, electrical convenience vehicles that are in there. So the definition specifically indicates that isn't intended to cover those. Personally, some of it I look at and go, well, if the energy's there and it's the same mechanisms, we may not have to. But I think regulatory wise, but it's certainly something that we should be mindful of and aware of. Certainly, I've had customers that have asked me to look at that, and I said, well, yeah, you've got a motorized shopping cart or a wheelchair type. Do you need to consider it? Is there a danger there? The danger doesn't necessarily go away because we've changed the name of the device or created a name. I think if it's about the energy that's there, it's about the potential for that battery to go into thermal runaway. Charging equipment listed, whatever. Portable batteries have to be listed in the label, and they give the same requirements that we saw in the IFC in terms of listing. All of you need to be looking for that listing mark on the product to ensure that we have that. And there's a proliferation. Like I told you earlier, I even one that appeared to be listed that looked like the right product was not. A buyer beware kind of thing. I think that that was a particular lesson for me. It's if the price was too good to be true, it's probably not true, and it wasn't. Ultimately, I made a complaint, and I don't know where that ended up going. They certainly gave me my money back. Same thing with individual devices needing to be plugged into a individual plug. Again, not using extension cords or power taps or multi-outlet things. I think it's intended to don't overload the electrical circuitry out there. Again, some of these places that you see this occurring, like what I spoke of earlier, where a operator of a building wanted to provide convenience for staff to bring in an e-bike or mobility device for their convenience and charge it, but you got to be aware that you don't want to create more of a hazard at the facility. Like I said, most of those I would just give them a place outside, allow them to charge outside. But, and there was even discussions with, well, if they get wet, it might mess their vehicle up. I said, well, they need to bring a cover for that. Don't put the charging operation in the exit card or exit enclosure. That's a little less onerous than that means of egress terminology that we saw earlier. The exit corridor is certainly a defined place, or an exit enclosure, like an exit stair, is a defined space. Me understanding and thinking about what I mentioned earlier, if you position this thing so that it blocks your only path to reach an exit, I would have a problem with that. I don't care necessarily what the words in the code or the standard would call out. We think about, is this device the failure of this device going to create a undue hazard of I can't get past it? And thinking about that, certainly if in your individual homes, if you have this, kind of like placing this at the door to your son's room or your daughter's room and having it charged would not be the best idea. And these are just understanding. One of the things that I tend to harp on a lot about is the why. Why are we doing this? We're doing this so that we can protect individuals and properties and operations and that sort of stuff from undue risk. And what is that undue risk? How much risk is acceptable? Something like I talked about with blocking a door with somebody not being able to get out or escape. That's a life we're talking about. And so certainly that is, but we're all able to make some risk decisions out there. So I'm going to turn now to energy storage systems. And I don't have as much detail here because these can get quite detailed in terms of the requirements. Depending on the size of them, there's a particular threshold limit on these that is established by both the fire code, which is shown here, the 20 kilowatt hour capacity for the lithium-ion batteries. There's a whole bunch of other batteries in there as well. We were kind of focusing on lithium-ion batteries. And then certainly in 855, we had a very similar type allowance or exact same allowance for the 20 kilowatt hours. There was a line in the sand drawn to make a determination of when we needed to get concerned. And again, I think a number of these you might think is the large energy storage systems that we might see in like that Surprise, Arizona fire, very large, the windmill picture that I showed. But again, these are showing up in a lot of common facilities out there, our business occupancies, our mercantile occupancies, where there's a need for an uninterrupted power supply that they utilize these. And sometimes we don't even recognize that that's what we have. Say I had some customers that as we dug in, we said, you have more than you think you have out there. And when we start to put more and more and more in there without knowing about it, that's when we're taking the unknown risk with these facilities that are out there. These are a few of the requirements that we pull out of the IFC. The 855 also has some of the requirements that are in there. When we're looking at risk mitigation, we got to understand that hazard or whatever. So there's a hazard mitigation analysis report that would be conducted and submitted to the AHJ to try to determine what the hazard was for these facilities. That particular requirement is showing up in both IFC and 855. The bigger one that I see, more emphasis kind of being pushed toward is this idea of testing in order to address the hazards associated with these installations. IFC has some requirements about testing in accordance with UL 9540A, which is also in 855. That's where we're looking at some of these things. We don't understand how to protect these unless we can conduct some testing to develop protection criteria. That's one of the things I know we've done extensively, not necessarily with the battery side of it. We're doing some of that with battery stuff, but with sprinkler protection, the best way to understand whether or not your protection metric is acceptable is run a fire test. These systems are very, very difficult to protect. They produce their own energy source there. They've got the flammable electrolyte in there, produce their own oxygen. They can burn continuously until they deplete the energy. We've seen videos, certainly, I think all of us on TV or things that reported events of certain things that are happening out there that we have to be mindful of. The chargers, energy storage management, again, listing. Some of that is going back to the uh, test labs and ensuring that these have an adequate level of safety. And that's ever changing as well in terms of what they're testing, trying to develop appropriate mechanisms to understand the hazard and then address that hazard that's out there. Separation requirements, 2-hour separation. I know IFC lays out this criteria for sprinklers. It says, hey, if you put these in up to the 50 kilowatt hours, you can use a 0.3 density for 2,500 square feet. Is that enough? I'm not sure if that is or not. If it's over 50 kilowatt hours, it says do a large scale test to figure that out. I think we need more of that. There has been some work done, I think, at Factory Mutual with some stuff. Reliable Sprinkler has done some fire testing with some stored arrangements where they're able to not suppress or extinguish that fire is probably the better word. They've been able to control it, to hold it in check, to hold it in place so it doesn't spread, but there's still a massive event that occurs that you have to absorb the energy and have enough water to be able to do that. Let's see here. Kind of wrapping up a little bit, we're seeing it everywhere. It's just going to continue to grow. We're going to see more and more and more of these devices. We have to become aware of the requirements that are current in certainly the IFC 855, NFPA 1, but this new 800, NFPA 800. That may take some time to get on the streets, but I think we all need to be at least mindful that it's being developed. Certainly, if you want to engage in that process, I'd encourage everyone to do that. If you have some information or thought, I know there's a huge interest in participation in the committee. I think they've got lots and more people that they're jumping on board with that to try to get in there and certainly maybe support what they're doing and why they think their stuff's okay. But this is an ever-changing fact. And I believe it's not just lithium-ion battery. There's new battery technologies that are at the forefront that may help us, but we have to be aware that they may also they may be very good at what they do in storing energy, but we have to be conscious of that going forward. So with that, I'll open it up to some questions. I think I saw some over there.
Yeah, thanks again, Tracy. Great presentation, and yeah, we have some. Looks like we have some really good questions here from the audience. First one from Tara. She's referring to that FDNY e-bike shop video, and it referenced specifically illegal batteries as being dangerous. Is that maybe one of just the primary issues of non-certified versus illegal batteries that are being used?
I believe that was a reference positive to non-listed product, counterfeit product, things like that are out there. They use the term illegal. I don't know in the context of whatever. My personal thought is I think there was a lot of non-listed, even counterfeit stuff that was out there. And I've had the opportunity to open some of those batteries up with some of the folks at the lab, and we look at a battery that's listed and the level of separation between cells and things inside the battery. You know, one of them has fairly robust separation and the next one has literally tissue paper. It's buying batteries that are from a reputable source that are listed. And I think that's what they were getting at. And we're all compelled. I told you earlier, I was guilty of going like one night, I thought, hey, gosh, that's a great price, buy. And then I came back and looked and said, and I ended up throwing the batteries away, said, I'm not going to keep them.
Daniel was asking about, wanted to know, do you recommend a standard ABC fire extinguisher or a lithium-ion extinguisher for, you know, where you keep like golf carts and other vehicles?
You know, one of the things that trying to extinguish one of those fires with a handheld fire extinguisher, I don't know that I would try to go. I mean, you look at the amount of energy that's produced, you're not going to put it out. You can cool that thing and control the event till it expels the energy that's being released. But I don't think you're going to necessarily stop it with that. I wouldn't encourage anyone to use that. Encourage everybody to get out and get away from that.
Okay. Bill was wondering regarding a parking garage question, and I know that's a very popular issue with lithium-ion. Parking garages with EV chargers, do they require, I think he's saying, additional FE or wet sprinklers requirements?
Couple things. Parking garages in general, in our world, open parking garages, 50% open around the perimeter, have traditionally been non-sprinklered. There was a perception or a thought, and I suppose maybe rightfully supported at the time, the vehicles that were in production at the time, this thought was that vehicle fires will not spread, or a fire in a vehicle will not spread from vehicle to vehicle to vehicle. It'll hold itself to a single vehicle. That's not true, certainly, anymore. We've had several fires in parking garages involving potentially EV vehicles or internal combustion engines, and have had some major losses. NFPA 88A or whatever has changed their tact on parking garages. The building codes and fire codes have changed their tact. We now have to sprinkle those garages. In terms of the amount of sprinkler protection, the NFPA 13 Discharge Committee, which I'm a member of, we changed the requirement for the amount of water that was required in a parking garage. It was what's called Ordinary Hazard Group 1, which is 0.15 GPM per square foot. We changed that to Ordinary Hazard Group 2, to 0.2 for 1,500, same square feet, but a little more water. And no basis. And we just thought, well, they're worse. And there is testing going on right now with the Fire Protection Research Foundation, where they're conducting a number of tests to try to validate how much water is needed for those. And if you're interested in that, go to the NFPA's Fire Protection Research website. And I don't think that report's been yet issued, but it will be out there. And that number may change again.
Great. And as mentioned, I know we're getting to the top of the hour, everybody, but we do have some really good questions here. And I know Tracy said he's willing to stick around here for a little bit to answer some of those. And then also, I know he'll be posting his contact information. We get something that comes up later and we can't answer it. Feel free to.
That would be in the handout if they want to download that. And certainly feel free to reach out and ask me a question. I'm certainly open to trying. And I think I told you guys the other day, I want to make sure we get this right, because the things that we have, failures that we have, are the things that everybody points out. Our successes. I want to have so many successes. There's nothing to point out.
Cool. Yeah, let's get go to some more questions here. Dennis is wondering about UPS systems with lithium-ion batteries. He's considering replacing a UPS unit with a 26/2.04 kilowatt batteries. Wondering if these will have a charging component in the system, he says, to keep the batteries charged all the time. What kind of considerations should he prepare for?
Well, that last stuff I was talking about, these energy storage systems, that 20 kilowatt hour limit is what the limit is now. Once you go over that, you're getting into a whole substantial number of additional requirements. And whether it's UPS, I mean, they're showing up with all kinds of equipment. I think the awareness thing is, look at that total storage capacity. I have seen some of the vendors that will tell you usable capacity, total capacity. They won't tell you total, but usable. The rule is total capacity, about the 20 kilowatt hours. I recently had that where they kept saying, no, it's the unit. I said, tell me this number. And then once they tell you that number, you go, wait a minute, now you're over. And again, I don't, it's just awareness. I want folks, it's about being aware of what you have and how many of these you have. I think they're sneaking in, not literally, but they're finding their way in there without somebody knowing it.
Mm-hmm. Tim was wondering about your thoughts on wrapping batteries with tape to prevent corrosion and avoid short circuits, especially on terminals.
Well, there was something there about protecting terminals. Certainly, we don't. The batteries as they're shipped should have their terminals protected so that they don't short between the two poles. That's the same thing that you would see on lead acid batteries. Certainly, it's just a protective measure to ensure that we don't have that short occur.
Okay. AJ was wondering, is the IFC or NFPA working on any regulations for data centers and UPSs?
I know data centers, a number of folks out there, data centers are very, very advanced now. We're getting into there. That is something that's, I guess, looked at with these same kind of problems. These things are not just being introduced in, one occupancy. That is one of the occupancies certainly that's being looked at.
Okay. Scott was wondering about IFC versus NFPA 855 and wondering if the 855 was more applicable in the U.S.
Probably the most widely adopted in the U.S. is the IFC, but it does sometimes and you can play, and I'll say play a a code game and say, well, that one doesn't apply, but this one does. As a risk or a fire protection engineer, I like to go, I want to know what all of them say and then decide for myself. I understand we got to be compliant with stuff, but decide for myself or in conjunction with a customer, what does this look like in terms of risk? So many times we go like, well, they don't say I have to do it, so I don't need to. But IFC is probably the most prevalent adopted fire code in the U.S.
Rick was wondering, what type of fire extinguishers would you recommend for outdoor storage areas such as bikes or bike charging stations?
Again, I'd have to look at it in terms of trying to fight those fires. I probably would just leave it alone because the dangers and the dangers of an associate or someone there trying to engage with that. If it's a small, not involving the battery fire, maybe you could deal with that. That could be. It depends on what that is, but I would not try to engage directly. And I think that's one of the things we need to, make sure we're letting our associates know in the building that, listen, we don't expect, because these things are, you saw some of this stuff, it will be a violent event. You don't need a hero with that.
C. Thornton question: do you think storage bags for all home tool batteries is a good idea, a good choice?
There are some products that are out there. I know, like I talked about airlines that have a product. There's another, UL is working on another standard, which I'm involved with, to develop enclosures that you could put your batteries in when you're storing them, when you're charging them. I think that's probably not even me personally. I've quit leaving my batteries in the charger in my garage after my friend James Gullenbo's house burned down. I just said I don't have an enclosure. They can be costly, but certainly being aware that these things are not infallible and the amount of energy that's released is something we should think about. It's a good idea. I think and you got to be careful of what you're buying. I mean, I've seen products out there that say, yeah, buy my product and it's great. Look for something that has some sort of validation and listing, like from UL, that says this is appropriate for this particular usage.
Great. We got a ton of questions here going. I know we're running up against here, Tracy.
Yeah.
We get 3 or 4 more questions in here, and then again, we have your questions. We'll get those to Tracy, and
I'll try to reach out to
answered.
And give them at least a quick blurb.
Yep. Let's do 1 or 2 here. Ian had regarding warehouse distribution centers with multiple EV lithium forklift charging stations. He said, what are some obvious visual indicators that could raise concerns if a charging station or forklift is not in good working order?
Obvious physical damage to stuff. I mean, when one of the things like returned batteries or recycled batteries, I've seen some of our customers say, yeah, we'll collect them and go. I said, those are probably some of the most dangerous batteries because something's wrong with that battery. They brought it back. It's possibly, but I'd look for physical damage on the battery, things like that indicate that they've been abused or whatever. I think there's some video of people, driving a nail or hitting it and causing a short circuit inside that causes a thermal runaway. But those are physical. That's the same kind of stuff you see with anything going. It's just physically damaged. It's got an issue.
Great. Yeah, I'm looking for some here people. We've had a couple questions from multiple questions from the same people, trying to mix up a few other people here, and then we'll move on. So Matthew was talking about the added weight of EVs and how much that's a concern in parking garages that you have to be aware of.
Different issue, but I think my original education was in structural engineering. And I'm going like, well, you put a vehicle that's heavy and a bunch of them, that is something that is being addressed or being thought about. They're substantially heavier than it's not an EV issue. It is in terms of the battery or any of that. They're heavy, and and it's something that we do have to, as we move more and more vehicles into these garages, someone has to evaluate. I think they have to have a structural engineer evaluate it and say, yes, this garage is strong enough to be, filled to capacity possibly with EVs. Or you need to at least understand that.
Sure. Susan wondering about using fire blankets and your thoughts on using them.
Fire blankets similar to like the bag or the enclosure. There's I've seen fire blankets used for throwing over something. It would certainly mitigate some of the projectile and stuff coming off of it, but most of these things that depend on the event, a lot of them are very violent. And I don't, anyone trying to engage with that event, get out, get you out, your family out, your associates out. It's not worth trying, in many cases, trying to engage with that stuff.
Okay. And we have one last question here from Timothy. And again, thanks everybody for your participation and your questions. Had a really great conversation here today. Timothy is wondering, given the unique challenges of suppressing lithium-ion battery fires, how do you evaluate whether traditional sprinkler systems are sufficient or if alternative suppression methods should be considered?
That's certainly something being looked at. I know Factory Mutual has done some testing, and some of their data sheets have some information on that. NFPA 13 doesn't yet in there, but and Reliable Sprinklers run some larger scale tests with lithium-ion batteries. I think it is something that's emerging. Just putting water on it, I don't think you're going to put it out, but you're going to control that event to protect adjacencies. It's something the best way to do it is run fire tests, and that's something that's coming. It's slow to come because it's not necessarily cheap, but understanding that the best way to understand that hazard is to run a test and demonstrate what level of hazard or what level of protection that you might have.
Great. Thanks again, everybody. Questions? Before we wrap things up here, I just wanted to hand it back to Tracy and see if you had any final thoughts that you wanted to give takeaways for the audience today.
Just in general, first, I appreciate everybody being on here and the wonderful questions that you guys have. I think certainly the fact that you showed up at this webinar and the numbers that you showed up and demonstrate that there is a concern about these things. I think just, continue to look at what products or items are being brought into your facilities and try to make sure that we don't allow these things to get out of hand in terms of what you have and have an event that leaves you unaware. There so many times we have people that go, I just didn't know. I think there's opportunities for us to know and just engage in that as much as you can.
Great. Well, Tracy, thanks again for the great presentation. And thanks again to our sponsors, Eagle Eye Networks and Kitted Commercial, for helping make today's event possible. Thanks to everyone in the audience for attending today. And one final reminder, this event was recorded and will be archived on facilitiesnet.com. Again, thanks everyone for coming today in appreciation and for your participation. And this will conclude today's event.